Good day viewers, and you are welcome to MLT channels. Today's subject matter is physics and the topic of discussion is projectile motion. You are all welcome on board. Without wasting much time learners, let's dive straight into details. Today, as we have said earlier, we are looking at projectile motion, and the first task is to define what projectile is. Projectile can simply be defined as two-dimensional view of an object in flight. It is referred to as an object that is launched in air and allowed to move freely under the influence of gravity. How do we explain this to a layman? When you have a body or an object that is covering both vertical and horizontal distance at the same time, we refer to such object as performing projectile motion. The parabolic movement of a particle is simply what the physicists refer to as projectile. Examples of projectile are common in real life world. We have example of projectile in sports, and a very good example of projectile in sport is a kickball, just like this boy that kicked the ball into the air. This is an example of projectile. Or a thrown basketball into the net. We have a basketball here that is performing this parabolic motion that scientists refer to as projectile. The basketball is performing both the vertical motion and the horizontal motion simultaneously. Examples of projectile can also be seen in one front. For instance, a fired bullet, a shot catapult, and a thrown arrow. This is an example of someone who is shooting a arrow and is an example of projectile. And the path that projectile follow is what is called trajectory. I hope this is clear enough, class. On this slide, we have learned that projectile can be defined as two-dimensional view of an object in flight, and it is a body that is launched into the air and allowed to move under the influence of gravity. Its example in sport include a kickball over the wall, a thrown basketball into the net, a thrown javelin, a thrown discus, etc. And examples of projectile can also be seen in one front: a fired missile, a fired bullet, a thrown arrow, or a shot catapult. And finally, we said that the path followed by projectile is known as trajectory. If this is clear enough, let's move to the next slide, where we shall be looking at what is happening to the vertical and horizontal motion that projectile is covering. Alright, learners, on this slide, we shall be resolving projectile motion into two components, which are the horizontal component and the vertical component. And there is a graph of projectile. Here is a ball that is launched into the air and perform the parabolic motion. Now, what is happening? We are interested in what is happening to the ball as it moves from the point of projection and reach the maximum height, then falling down to the same level of projection. What is actually happening is that the ball started with an initial speed u. Then while it is launched in air, it reaches a maximum height h, and the time it takes this ball to reach the maximum height is what scientists refer to the time to reach the maximum height t. Then at the maximum height reached, the ball falls freely under the influence of gravity to the same level of projection, which took the ball time of flight to fly from the point of projection to the return to the same level of projection. While the ball covers a vertical distance h, it also covers a horizontal distance r, and this is what we are interested in. We are now resolving this into two different components. Then with that, we'll get expression for our acceleration due to gravity g, which is acting on the body as it is launched in the air. Then also we'll get expression for the initial speed of the body as it is launched in the air, the final speed v in which the body is moving, and the total distance covered by the body along the vertical and the horizontal axis respectively. Now, in order to start, let's get expression for our initial speed u. So what we have here What we have here on the projectile graph is what we have interpreted here to form a right angle triangle. On the projectile graph, we have the initial speed u, and here is our initial speed u, that is a diagonal line. Then we have the initial speed uy, that is the initial speed along the vertical axis, and here is it also in a right angle triangle. And we also have the initial speed ux along the horizontal axis, and that is what we have here along the horizontal axis. Then convince yourself that if this point is ui, here is also ui, because the two lines are parallel. Now if you resolve horizontally, if you are resolving horizontally, that means we are considering u and ux if you are resolving horizontally. Then the next question we ask ourselves, because this is a right angle triangle, what does our u represent? Actually, our u represents the hypotenuse side, because that is where angle 90 is facing. Then what does our ux represent? Our ux represents the adjacent side, that is where nothing is facing. Then the next question we ask ourselves is that which function of our SOHCAHTOA connect adjacent and hypotenuse, and that is actually cosine function. So we can now say that cos theta equal to adjacent, and our adjacent is ux over hypotenuse, and hypotenuse is u. So if you make ux the subject of the formula, therefore ux now will be equal to u cos theta, and that is our initial speed of a projected body along the horizontal axis. And let's put that here. Our initial speed along the horizontal axis ux equals to u cos theta. Although we are meant to start with acceleration due to gravity, but that escaped my mind. But the moment we are done with the initial speed, we go back to acceleration due to gravity. Then if you resolve vertically, if we should resolve vertically now, that implies that we are considering u and ui. Then we have established that our u is hypotenuse, then our ui is actually the opposite side, where angle 90, where angle theta is facing. Our ui is opposite side. So the next question that comes to our mind now is that which formula connect opposite and hypotenuse, and that is sine function. So that implies that we have sine theta now which is equals to opposite, and our opposite is ui over hypotenuse, and hypotenuse in this case is u. So if we make ui the subject of the formula, that implies that ui now will be equal to u sine theta, and that is our initial speed along the vertical axis. So let's put that here. Our initial speed along the vertical axis, which is ui, equal to u sine theta. Now we've gotten our initial speed along the vertical axis as well as our initial speed along the horizontal axis. What will now be the value of our resultant speed, which is combination of both the vertical and the horizontal? What will be this? So our u here, which is the resultant, if we should apply Pythagoras theorem here, if we applying Pythagoras theorem here, if we apply Pythagoras theorem here, this u is square will be the sum of the square of ui and ux. That implies that our resultant, which is our initial speed of thrown, is square is equals to the sum of the square of our initial speed at the horizontal axis as well as the vertical axis. And with that, we have been able to determine the initial speed of our projectile motion. Then the gravity, the acceleration due to gravity, G. A body that is moving along horizontal plane is not affected by acceleration due to gravity. Definitely along the horizontal plane, our acceleration due to gravity is 0 meters per second squared. Then as the ball is launched, as we launch the ball into the air, the ball is first moving against gravity until it reaches the maximum height. That implies that as the ball is going up along the vertical axis, the acceleration due to gravity will be negative. It's negative because it's moving against gravity. So as it's going up, let's call this G up, it is negative. Then here, at maximum height reached by the ball now, the ball is now falling under the influence of gravity. So for a falling object, G will definitely be positive. So as the ball is falling, our acceleration due to gravity, let's call this down, our acceleration due to gravity is positive. So the next quantity we shall be looking at is the final speed at which the body is moving. And for the final speed at which the body is moving, we have to adopt the first equation of motion that says V equal to U plus AT. Then we need to take note here that since we are talking about a body that is launched in air, our A now will become G, because anybody that is, or anybody or any object that is covering vertical motion is affected by acceleration due to gravity. So now, to get the expression for our final speed along the horizontal axis, which is Vx now, that will now be equal to Ux, which is our initial speed along the horizontal axis, plus, we have said that our A becomes G plus GT. Then we have established earlier that our G along the horizontal axis is equals to 0 meters per second. That implies that this will now change. Our Vx now will become, we substitute the value of Ux that we have here. Our Ux, we have established that is U cos theta. So that's what we are substituting here now. So we have U cos theta plus our G is 0, then T. Then that will make our time to be automatically equal to 0. So therefore, our Vx, which is the final speed along the horizontal axis, is equals to U cos theta. Okay, theta is omitted here. So let's put the value of our final speed at which the body is moving along the horizontal axis, Vx, and that is equals to U cos theta. Also, as we have gotten expression for our final speed along the horizontal axis, we also have to get for it along the vertical axis. And we are still using the same formula, which is the first equation of motion, which is V equals to U plus AT. We are still using this same formula to get the expression for our final speed along the vertical axis. Then in doing that, we will have Vy now, which is equals to Uy plus, now the body is launched in air. If you look at here, the body is launched in air, so it's moving against gravity. So since the body is moving against gravity, that implies that our G here will be negative. We have established that earlier, that a body that is moving, that is going up or thrown up, is moving against gravity, and at that moment that will make our G to be negative. So here we have minus G, then into brackets T. Then finally, our final speed along the vertical axis will be, then the next thing now, we substitute the value of Uy, which we have already established under our initial speed to be U sine theta. So that implies that our final speed will now be equals to U sine theta minus gt, and that is the formula of our final speed along the vertical axis. So let's put down that here. So our Vy equal to U sine theta minus gt. So far we've been able to determine what is happening to this ball as it's going up in terms of our gravity, which is 0 along the horizontal, negative as it's going up, positive as it's falling. We have also derived expression for our initial speed U along the vertical axis. Our Uy, which is this, equals to U sine theta. Then along the horizontal axis, our Ux equals to U cos theta. And we have said that when we combine Ui and Ux, which is what we have here, using Pythagoras theorem, we shall get the value for our resultant initial speed, which is U squared equals to Ux squared plus Uy squared. Also, we've also gotten expression for our final speed using the first equation of motion. We've gotten an expression for our Vx, which is U cos theta, as well as our Vy, which is U sin theta minus gt. So what we are left with now is to now get our resultant final speed, which will be V, and our V now is squared, same as our initial, will be equals to Vx all squared plus Vy all squared, and that is our final speed along the vertical axis. So what we are left with now is the total distance covered by this object, by this body, as is along the vertical axis as well as along the horizontal axis. And in order to achieve that, we need to adopt another equation of motion that says S equal to ut plus half at squared. Then we have said earlier that our A now will turn to G, because we are talking about a body that is launched into the air. So we put that in our mind, that A equal to G. Then now, to derive expression for the horizontal distance covered by this body, we represent that as Sx, and our Sx will be equal to Uxt plus half gt squared. And we've established earlier that along the horizontal axis, we have demonstrated that our g is equals to 0 meter per second, because an object that's moving along horizontal axis is not affected by gravity. Then that implies that our horizontal distance, which is xx now, equals to, then substitute the value of ux here. You have u cos theta t plus half we shouldn't forget that our g is 0 t squared. Then that will make everything we have here to become 0. And finally, our total distance along the horizontal axis xx equals to u cos theta t. And the final task for today's class is to get expression for our vertical distance, which is sy. But before we do that, let's put down the value here. Our sx, which is the horizontal distance and is actually the same thing as the range, is equal to u cos theta t. Now, to get the expression for our vertical distance, which is sy, that will be uy t plus, that plus isn't good enough. Let's recap that. Plus half gt squared. Then we have also established earlier that along the vertical axis, as the body is launched into the air, g is negative. So that will make g to be negative here. Then we shall get our final expression for our vertical distance. So our sy now, substitute this value, which is the value of our uy here. Then that implies that our sy now becomes ui, that is u sin theta t, minus half gt squared. The reason why it's minus is because our g is negative along the vertical axis, and this is what we want to achieve on this slide. On this slide, we want to resolve our projectile motion into two different components, which are the vertical component and the horizontal component respectively. And we've been able to do that. We've gotten an expression for acceleration due to gravity, our initial speed, as well as our final speed, and also the total distance covered along both the horizontal axis and the vertical axis. So now, also, as we have gotten resultant for initial speed u, resultant for final speed v, we are supposed to get resultant for our distance too. and the resultant of our distance also, that is s squared, that will be equal to sy squared plus sx squared. And that will be all for this video. By the special grace of God, in the next video, we shall be talking about the terms used in describing projectile, which are the time of flight, maximum height, and the range of projectile. Not only describing them, we shall derive all their formulas and use them to perform simple calculation. I hope you have gained one or two things in today's class. If you had, don't hesitate to join me in the next video. 23 minutes already gone down like 23 seconds. I remain my humble self, Engineer Oladepo, your host and your amiable online tutor. Bye for now.